Okay guys, so in my last video I show you how to build the board or waste board on this CNC machine, but there's still one more upgrade just I keep recommending people to upgrade is the spindle, but I haven't done it myself, so I think today is the day. I got here a 400 watt spindle. I usually recommend people to get 500 watt, but I only get 400 watt. Well, it's just potato. It's just smaller potato. To control the speed of this spindle, you will need a motor driver or speed controller for DC motor. You can control the speed with this potentiometer, or also the PWM signal just come in here. I probably prefer this one, the PWM, because you can just control the speed with the G code that you generate. And you also need a power supply. This is 48 volt 10 amp, so 480 watt, which is more than enough for this 400 watt spindle. First of all, I just want to test if I can control the speed of this spindle using the PWM signal from this control board of the CNC machine. Okay, so here's the back of the CNC machine, and this is the control board. So this is where the spindle power just plugged in. I just going to unplug this because I'm not going to use that spindle anymore. And here I have the laser ports that have 3 pin. One is 12 volt and PWM in the middle and the ground. So I don't need the 12 volts, so I just need the 2 pin is the PWM and ground to control the speed of the other spindle. So let me just try to get the signal out from here. So I need a 3-pin connector here. So I just use the kind of like the potentiometer just come with the like motor speed driver. Just I'm not going to use. So I just going to cut this and take the 2 wire like the ground and the PWM. So I just plug it in here and well, just cut 1 wire. I just want to make sure that I'm going to cut the right wire. Okay, so this one is the one that I'm not going to use. So I'm just going to cut it. Okay, and so now I'm just going to connect this PWM to the motor driver and then connect the power to that driver and see if it works. Okay, just make sure you don't mix up the wire. Okay, so I have the spindle connect to the motor output side. Now I'm just going to have to connect the power supply to the motor driver. Okay, before connecting the power to here, I just have to make sure that it have 48 volt output here. So I'm just going to plug it in. Yeah, so I have 48.3 volt. So that's fine. Okay, so now I just connect this to the input of the motor driver. Okay, just put the power supply on the side here. This here, spindle on this side. Okay, so I have the power supply on this side, the motor driver, the spindle here, everything is connected. Just make sure that you have enough space for this to turn. This is kind of like the fan to cool down the spindle, so make sure that you have space. Well, I'm just going to plug in the CNC machine and the power supply and test the spindle speed with the software, with Candle. Okay, so here in Candle you have the spindle control here. You can just put the speed, maximum speed about like 12,000 is the speed of this spindle. So just set it right. Okay guys, so after testing with candle, the spindle didn't turn. I think just there's no PWM output from the laser head connectors. So I just have to get the PWM from the MOSFET directly. So I just going to do some little soldering, a wire from the PWM pin go to this wire. So let me just do the soldering quickly. I will show you where to solder it. Okay, so now just go back to the back of the CNC machine. I just want to unplug this cable for now so I have more space. Okay, so as you can see, this big transistor here is the one just convert the power and input it into the spindle. So we have the lower pin here is the PWM and the upper one is the ground pin. So I just solder two wires, one is from here and one's from here to the motor driver. Okay, so it wasn't too hot. I have the two wires soldered to the PWM pin and the ground pin. So now I just connect these two wires to the motor driver. Okay, so now I have it connected. Let's just try again. Okay, so I just have the spindle turned. So I set in candle 10,000 RPM. So let me just try a bit lower speed. So here is 200 RPM. Wow, it seems like a lot slower. Wow, it seems to be working now. So this problem is solved. I have the PWM come here correctly. So now let me just design and make the spindle holder for this. So for me, I don't want to make a holder just to be 3D printed because a lot of people just they don't have 3D printer or don't want to like kind of buy a 3D printer just for this and learn a whole new set of skill. Like you have a lot of problem with 3D printer too. So let's just stick with this CNC machine and I'm going to make something that you can just mill down from this CNC machine. Okay guys, so here's my design for the spindle holder. It looks almost the same as the ones already on the machine. So the difference is just this part is have the diameter of 52 millimeter, so it can hold my 400 watt spindle or other spindle. Like if you have from 200 watt to 500 watt, it will be fine. So the height of this spindle holder is 36 millimeter, so I will have the same working range in the z-axis, and I can also reuse the linear bearing just already on the original holder. As you can see, just you can 3D printed this part out very easily, but as I told you before, I will stick with the milling machine. 36 millimeter is pretty thick. I don't have the bit to mill this out in one piece. And I also think that the working range on the z-axis on the 3018 CNC is very limited, and so it will be hard to mill this piece out in one piece. So what I want to do is just I'm going to divide this piece in three pieces, the bottom one and the two top one. Each one will be 12 millimeter thick, so it's going to be very convenient because I already have the plywood is 12 millimeter thick. So let me just show you the pieces. Here's the bottom one. Well, it's look the most complicated one in all three pieces. Here's the top one. You will have to make two of this to stack on top of the bottom one. The bottom one look a bit more complicated, so I'm just going to show you the cam process on that piece. Okay, so the cam part in Fusion 360 is very easy. You just open the file just I already saved in step format. Now just click on setup, choose the reference point, and here I just put 10 millimeter side offset and 0 on top, and just click OK. And now I just going to do pocket clearing for this part, and this. So I just go to 3D pocket clearing, choose a tool. I'm going to use a 3mm flat end mill, and I just reduce the plunge rate to 150mm per minute. Disable this. Here I just do selection. So do this and this and this. And here two centers inside the boundary, and I want to put -2 for additional offset. So it's cut all the way out here. So I put 2, 1, and here maybe -0.5. So it's cut all the way through the stock. And here I put like 0.01, so it's more precise and nothing to leave. And here I put shortest path, and here maybe I just increase this a little bit to 5 degree. Okay, so it look correct to me. It just go all the way through the bottom. So now I just going to cut this piece out of the stock. I just use 2D contour and choose the same tools here, and just go to select the contour here, and do tab maybe 4mm and 1.5mm high. And here, well, I just reduce this to 1.5 and -0.5. And I'm going to do multiple depth. This is each time 1mm step down should be fine. And disable this, and that's it. Okay, so it's look pretty correct to me. So let me just show you how it mill on the machine. Okay, as you can see here, I have pretty clean cut for the bottom part, so I just continue on the two top parts, and then I will show you how I put the thing together and put it on the machine. Okay guys, so after cleaning up, I have here three pieces, and they look like kind of really lined up to each other, so I think that's a good sign. So let's just start to install these pieces on here. So to make it easier, I just unplug some wire here, so I have more space. Okay, so I have to dismount this part out, so I think I'm just going to dismount the whole Z-axis from the rail and the last screw here, so it will be easier to work with. Okay, so now it's out. I have to take this part out, so I just going to have to uninstall the lead screw and also the rail from this block. Okay, so the spindle is out. You can use this for something else. Okay, so now just take like M4 bolt, just pound it in here to push the rail out. Okay, so now this part is out. Next step, I'm just going to try to take the bearing out of this socket. Well, this one is easy, it just slide right off because this gets too loose. So it's about time to change it anyway. Okay, so I have this coupler is like for the lead screw and the motor. I think it's about the right size to like kind of pound this out here. It's not going to damage the inner part of the bearing. Okay, so now I have the whole thing dismounted. I have the bearing out here. So I just take the bottom part and the nuts for the lead screw of the Z axis. So I'm just going to try to install it on here. So just press it in. Now you can just use the hammer. For me, I probably prefer something a bit more gentle like the C clamp to just press it down nicely. Okay, so now I have the nut just pressed in here. I just got to drill a small hole, two small holes to kind of use the screw to like bolt it down. Okay, so now it's bolted down. This is not going to move. You're going to stick with this so you can move it up and down, no problem. Next step, I'm just going to try to like press the bearing in here. So same thing, I'm just going to use the C clamp and put some kind of piece of steel or aluminum on this and to press it down nicely. Or you can just use the hammer, just tap it nicely. Okay, so it's almost at the bottom here, so I think that's good because more than half of the bearing is already in the piece of plywood. Okay, next step, before putting one piece of the top part on this, I'm going to put some like wood glue all around here. Layer here, and then I'm going to just put it on and just tap it down. Okay, so now I just put the top part on top of this. Now, of course, I will have to tap at the bearing place first for it to go down. Okay, so now you can see that the linear bearing kind of help to align the two pieces together. So next step, I'm just going to install these two bearings here and put the last piece on top. Okay, so now I have all the layers just lined up and stacked on top of each other. So I just want to use some C-clamp to clamp them down together and wait for the glue to cure. Okay, so now the glue is kind of dry. What I need to do next is just drill the two holes through the two sides here, so I can use the bolt to tighten the spindle later. You can use whatever drill bit you like. For me, I use 4mm because I got to use the M4 bolt later. Okay, so the drilling is easy, so now it is ready to be installed back on the machine. Okay, so after install this on the machine, I realized that one thing, just the center of the spindle is kind of like moved forward a little bit compared to the old one. So what I need to do is just have to move the axis along with the z-axis a bit backward. So that way I have the spindle is kind of like right at the edge of this, and if I move this back, it will be at this edge. So it will cover the whole range of the machine. Okay, so now the tool can cover the whole range of the y-axis. So that is done. Okay, so I just rewired the machine. As you can see here, it can move up and down really smoothly on the z-axis, no problem. So as you can see that the weight of this spindle doesn't really affect the movement of the z-axis at all, and it's really tight. You cannot really push it down, so the anti-backlash here also work very well. Okay, one thing very important that I need to show you is how to set the maximum spindle speed in Kendo, because if it doesn't really set right, the spindle not going to turn at the right speed that you set in the G code, and the part won't be cut correctly, and it's probably not set correctly right now because I just checked the setting of my CNC machine, and it wouldn't set correctly even for the old spindle. So let me just show you how. Okay, so here in Kendo, if you type in the comment $sign here, and you most likely will see that at the $30 your setup will be 1000, so you will have to reset it to the maximum speed of your spindle. So for me, I just type in $30 equal 12,000 because the maximum speed on that spindle is 12,000 RPM. So that's it. And here on this side you have the spindle menu. Just expand it, and you see that the speed here, maximum speed here, is right now is set at 10,000. To change this, you go to service, settings, and then change it here. You can set spindle speed maximum is 12,000 RPM, and then click OK. Okay, so now the setting is done on the computer. Let me just see how the speed control just turn this motor. So I will start with very slow, probably 50 RPM. Okay, it doesn't turn, so 50 is probably too low. Let's see 100. Okay, at 100 RPM it start to turn here. It's slowly, so let me just increase it. 500. Well, as you can see very clearly, it's turned a lot faster. Let's see 1000. Okay, I'm not sure you can hear it, but it's like start to get a bit louder. 2500. Well, you can hear it now, I think. 5000. 10,000. and 12,000. Okay, so I think that the motor turned at the right speed, so everything seems to be fine now. The one thing just I don't really have a project right now to prove that the Spindle can perform a lot better compared to the old one. One thing I can be sure just is a lot more quiet compared to the old one, and it doesn't really shake as much, so it will perform better, I'm sure. This is one of the upgrades just you can do very easily using this CNC machine itself, and you don't really need any other type of equipments. For the milling part, if you don't have the 12mm thick stock like I did, you can use any other type of stock. I don't know if it's thicker or thinner. Just get the model in the link that I share in the description, then divide it in the layers, just whatever thickness just you need, just fit your stock. And that's it.